Hello everyone, welcome back. So the next session, Zoltán Lehoczky's second talk today is called Security Scanning, an Orchard Core application. In this talk, he will show you how you can scan your Orchard Core app for security issues with Z-Attack proxy, also doing it automatically as part of UI testing.
That's right. So this will be my third and final talk, but this will be the best one because I will show you some code. And we'll talk about security. But before that, just for those people watching the recording, I'm one of the co-founders of Lombik. You might have seen me under the name Piedone on GitHub, issue tracker, discussion board, or during the weekly meeting, or my head talking on the recordings of tutorials. But when I'm not doing that, then I'm sometimes doing some UI testing and other testing code, because the issue is that your app is insecure. Sorry to give you that memo now. I'm sure everybody is a very diligent developer here, but still, have you thought about the proper authentication first and then authorization for everything in your app? Are you up to date with your HTTPS certificate, your HTTP, anyway, whatever that is, HSTS configuration? You know that browsers can preload your site via HTTPS. Are all the content policy and security headers properly configured? Are you properly preventing via input validation and encoding, cross-site scripting, cross-site request forgery, and all of these crosses? Are you sure that there are no information leaks in your app? And so on and so forth. The point is that security is a complex beast. There are a lot of things to take care of and a lot of little bits that you have to get right. It's hard, but it's not impossible. Now, if you don't do that though, then they will come for you. And by they, I mean the hackers as LinkedIn sees them, because apparently this is how a cyber criminal looks like. But jokes aside, having security issues is a real problem because it can have real business impact, it can have a real legal impact, open up you and your company to litigation if you have an information leak. These are nowadays strictly regulated. But there's a tool, there are multiple tools actually, but there's one tool I will talk about today that will help you with that, to help you get your application security right, and that's Z-Attack proxy, or ZAP for short. ZAP is a fellow open source project, and it's the most popular web application scanner out there, according to them, but I kind of believe it because it's a great piece of software. It's available as a desktop app. I will show you that, and it's also available via the command line interface in Docker containers, what will be something that we'll get back to later as well. But now let me show you ZAP in action. So what I have here is not actually this. Let me get back to the front end here. What I have here is a simple Orchard Core application running vanilla 1.8 because when I prepared this demo it was more than 2 days ago. So vanilla 1.8, let's see what ZAP tells us about this. So what I'm doing now is opening ZAP. So this is ZAP's desktop app. It has this dashboard here, but there are two things. It's quite complicated and it can do a lot of things, but there are two things that we'll see today. One will be the automated scan, and the other one will be this manual explore feature. So let's try the automated scan first. You might have a guess of what this is about. It's about automatically scanning for security issues your application as far as ZAP can discover things. How it works is that you have to give it a URL and then some configuration. This is a very simple to use feature, but still it's powerful. Then you have to use either a traditional spider or the Ajax spider or both. Spider in this sense is a web crawler. So what Zap does is that it opens this URL that you specify and it crawls through the whole website, tries to discover all the URLs. Now the traditional spider is just inspecting the HTTP output or the HTML output and trying to get to the other URLs. The Ajax spider also supports SPAs. Now this site is not an SPA, so I will disable that. So we'll use the traditional spider, no Ajax spider, and I actually need the URL from here. So I'm copying that into the URL to attack, and then attack. And what happened first? It was very fast, but what happened as at the very first thing, is here. Was that it actually visited a couple of URLs. So this is the output of the spider, the mentioned crawler, and you see that it visited pretty much all the URLs on our site. And there were a couple of other URLs to external services, like this Google Fonts one, that it ignored because those are external. We don't want to scan those. And once the spider finished, what we actually can't see, but what also happened was a passive scan. The passive scan of Zap is pretty much that Zap is inspecting the HTML output and also all the headers in the HTTP response. And it just inspects everything. It sits there passively and it tells you whether if it misses something security-wise. But there's also something called the active scan, which actually tries to attack your application. So it's a lot slower because it does a lot more. And one of the things you can see here are various bogus URLs being opened. So, for example, it tried to open this admirer.php, which is, I guess, some kind of a security vulnerability in a PHP CMS out there. Typically, WordPress specific attacks are like this. There's a lot of this as well. You can fine-tune, by the way, Zap not to attack for PHP because Orchid Core won't be broken by PHP attacks. But this is just a very simple automated scan, so everything has run. And now we can also see the outputs of all of these. And this is how it looks like. If you go to the alerts tab here, it contains all the security alerts. For example, one big one is that the content policy security header, content security policy header wasn't set, which contains a lot of information for the browser for it to protect the user. So, for example, here you can say that you and the browser should only load frames from the current domain and nothing else. This prevents users, the browsers being instructed to load iframes or frames from somewhere else, which is a common attack if you forget to or don't prevent cross-site cross-site scripting attacks. And there are a couple of other alerts as well. Again, a missing header one here, and a couple of others that are not necessarily something that we want to care about. For example, the powered by header is leaking information. That's of course advertising that this is an Orchid Core app. Technically, that's a security issue, but I think that's one that we can ignore. Because remember my talk from yesterday, we want people to know that you are running an Orchid Core site, your build with can discover it, and we can have nice numbers. In any case, Zap will find a couple of issues, and you can, for each of them, you can decide whether that's something that you care about or not. Usually, it's a good baseline to take everything that Zap finds and try to understand each of these. Now, this was the very simple automated scan. There's the previously mentioned Manual Explorer as well. Let me launch that too, and we'll see what that actually is. It launches its own browser, so Zap can bring its own browsers as well, or it can use the built-in ones. We'll just continue to here. Now, what the Manual Explorer does is that it's running the passive scan, but it doesn't run the spider. So you explore the site, you click around, and Zap is just sitting there and trying to inspect the responses, and will tell you if anything is a security issue. So first, I add the current domain to the scope, which means that Zap will now search for issues here, and then we can click around. For example, I open the blog post, and here on the right away, we see that these little flags have lit up, and we have, for example, 3 medium alerts. And this is exactly the same thing, or exactly the same kind of things that the automated scan found. But now I was the web crawler. Now, why would we do that? The crawler can't reach every part of your site. For example, it can't log in. You can instruct Zap, by the way, to log in some intricate ways, but by default it can't log in. It won't find URLs that are not linked from the start URL, of course. Since it's a crawler, it works like a crawler. If something is unreachable for it, it won't check it. But with the Manual Explore option, you can do that. And you have to keep in mind that Zap is a tool for security researchers, penetration testers. So it's not like that they run Zap, see the report, and that's it. But rather they use Zap as a tool to find issues with the site. But they are manually digging around as well. And this is the way to do that. But the question now is, can we automate this? So we don't want to do such security scans all the time. We are not security researchers, we are not pen testers, we are Orchard Core developers. So how can we use this to continuously scan our Orchard Core application for security issues? And the answer is, remember that I mentioned that the Docker CLI option of Zap will be important. This is very important. We'll of course use Zap, but from the command line. And we will use the Lombric UI testing toolbox project of ours, which is about UI testing, as you may have guessed from the name. But it also does a lot more, including integrating Zap security scans into a UI testing suite. So as part of your test arsenal, you can do security scanning too. And it's all from C#. You don't have to care about anything. You just use it. So let's see that in action as well. And I will now jump ahead, because this application here is, as you have seen, insecure, but I will now do some magic and fix that, but I will only explain that later, because I have to run this test now, so it actually finishes until I get to it, because it will take a couple of minutes. Such a security scan, by the way, how long it takes depends on your app. For this particular small app on my machine, it takes about 15 seconds, including the ramping up Docker and everything. On this laptop, for whatever reason, it takes like 3, 4, 5 minutes, and it's not using the resources. I don't actually know why. But anyway, for some reason it takes that long. But before we get to that, this is how you can automate it. What we are looking at now is a UI test. It's a test class. If you are familiar with XUnit or something like that, it's the same thing, but it's a UI test, not a unit test. So, for example, this one here, as you can see from this fact attribute, it's an XUnit test, but herein we don't have unit testing, but a security scanning UI test. Specifically, this here is the security scan. So we have a one-liner, and pretty much that's it. The rest of it is just plumbing. And by the way, all of this code is up on GitHub. I will show the URL to it later, so you don't have to understand everything right now. This one-liner is the security scan itself, and as you can see from the keyword baseline here, this is just running what in ZAP terminology they call the baseline scan, which is just the passive scan. This is faster. It doesn't run the active scan. It doesn't try to actively attack the site, but of course it's not complete. So I previously run this test so to be able to show you the results right away, and so we don't have to run it again. And this is the output of it. So remember that in the ZAP desktop app we have seen the alerts. Now when you run this in an automated way, such a nice HTML report will be generated. So you can come down, go down here and see which issues ZAP found with your app. For example, again we have that the CSP header is not set. We also have another header issue, but for example we don't have the powered by header issue. Remember that the Orchid Core powered by Orchid Core header was sent and ZAP complained about it. We don't see it here. We don't see it here because in the UI testing toolbox we are using an Orchid Core specific configuration for ZAP. We fine-tune settings a little bit so it doesn't complain about things that don't matter. For example, this one, of course this is opinionated, but I think a good baseline. For example, it doesn't complain about this. It doesn't complain about HTTPS issues because we are running a local site. If you have some certificate problems or HSTS is not set, that's not an issue. This is a local app. And stuff like that. We fine-tune the configuration so you only get alerts for what really matters. And these issues actually matter. Now, by the way, ZAP will always generate an HTML report, but behind the scenes, what's also generated is a JSON report, which is very nice, easy to read, of course not. But this contains the same thing, but don't worry, this is not for you, this is for machines. And this is also important, because this report is in the format called serif. That's an open value standard for such security tools. They can use this for data exchange. What this means is that there's support for it. For example, there's a library, a NuGet library by, I believe, Microsoft, that can parse this and present this in a .NET, as a .NET object, pretty much. And that's important for us because we want to be able to run assertions on it, what happens behind the scenes. Let me check back to Visual Studio and see in the Test Explorer whether the test has run, and yes, it has run. So I will now continue with the magic, because previously this test has failed. Our app has security problems, but I did some magic in the beginning when I opened Visual Studio, and what I did is that I uncommented this line. I added this line. Now you may know about the security module in Orchid Core. With that, you can configure some security headers from the admin. We are not using that. The reason why we are not using that is because that's site-specific and admin configurable. Now, if you have a single site, it's great. But if you have more than one site, you have a multi-tenant application, or even you have hundreds of sites and you don't want to maintain this header configuration individually for every site, then you have to have some better approach. And this better approach is this magic method call here. This configure security defaults, blah, blah, blah. This is coming from our helpful libraries module. Again, this code is up on GitHub, so you can check it out in detail. And it sets up all the necessary headers in a context-aware way. So, for example, if you turn on the reCAPTCHA module, then it will add security headers so reCAPTCHA can be used. Because by default, if we lock everything down with the CSP headers, the reCAPTCHA wouldn't be loaded because it uses an iframe, it runs some external scripts. So by default, we wouldn't allow that. But if you enable the reCAPTCHA module, we will know that okay, you want to use reCAPTCHA. We will add the necessary headers, and it will work. So there are a couple of things like that make it easier. And usually, what you need on your site is this, and that's it. There's of course more to it, but you get a pretty good baseline that has all the necessary headers, other configuration for your application to support a secure way of hosting it. And once you enable that, we actually get a passing test, and this time it was 2 minutes only. So something got faster here. That's the magic of demos. Sometimes it breaks on the fly here on the podium. Sometimes it's half the time. But there's more to it, of course. This one-liner test here was, of course, very simple. It just runs the passive scan and that's it. But first of all, you can also run the active scan, which is another one-liner here. I won't run it now because it would take like 15 minutes, and it would actually use resources from the app. But that's what I recommend you also using. And this is something to run for pretty much every pull request, I think. Well, not on every commit, for every pull request. But still, when you open a pull request, before merging, I think the security scans should be run. And you can configure them all the way. So this example test here, it uses a non-standard configuration, some custom configuration. So what you see here in this delegate is pretty much ZAP configuration, but in .NET. So this is something that you can also configure in ZAP from the UI. You can also configure in ZAP from YAML, because they use a YAML format for that. But here it is in C#. For example, you can exclude certain URLs from the scan. This is important because if you have a blog with 150 posts, like several of our sites have, then you don't want to scan each and every blog post. It's the same thing. It would take a lot of time. So instead, you scan 3 blog posts, and pretty much that's it. You can also disable rules that you think that, okay, this is a false alarm, or we don't care about that. You can also disable rules for specific URLs. So you can disable rules globally, you can disable rules for specific URLs, and you can exclude URLs altogether from the scan. And another magic thing, I mentioned that ZAP can't log in. Well, it actually can with this sign-in configuration. So this is an example of a custom configuration. There's a lot more to it, and we have it documented, so I won't go into more details. But the point is that there's a lot of configuration available for ZAP, and that's also exposed in .NET. And assertions as well. So as I mentioned, the JSON that ZAP spits out is a standard one. It's a serif log, serif formatted log. Now that we can also parse in .NET what happens behind the scenes, and what, not behind the scenes, but here in the foreground, is that you can also run assertions on it. So you can say that, okay, I want to have 0 alerts, which is the default. So probably that's the best thing to aim for. But if you can't have that, then you can use this, because it's just a .NET object with a lot of items in an array, pretty much. You can use that to run custom assertions. You can say also here that you don't care about certain things. ZAP is not perfect either, so it can have can find issues that are actually false alarms. You can use assertions as well to just exclude those. All right, so I mentioned code is up there on GitHub. So I welcome you to inspect it in more detail. The code of the UI testing toolbox is also up on GitHub, so that's fully open source as well. As mentioned, ZAP is fully open source as well. If you are inclined to look into its code, it's Java, by the way. But it's a very friendly community with some great people. Sebastian doesn't want us to look into the code of ZAP, apparently. But you are free to do that. So that was it. Thank you very much. And if you have any questions, we can talk about it.
I wanted to ask if this testing framework is intended only for use in the CMS variant, like not in the framework, because we wanted to use it like a month ago, and we were not able to set it up on framework only without the CMS.
It should work. So it doesn't really have anything to do with the CMS except for those parts that actually interact with the CMS part. Like we have extension methods for posting a content item and things like that. But otherwise, the basics should work. Yes. We have also used it in applications that don't really utilize any CMS features. Let me know. We can talk about that later in detail. Probably there's some misconfiguration there.
Yeah, okay.
Any other questions? Comments?
All right then.
Thank you very much.
All right, thanks.